Chapter 4, Section 2 deals with multiplying and dividing monomials. According to our content objective, it says students will use the law of exponents to multiply and divide monomials, and the suggested pacing says this is going to be a 2-day lesson. Yesterday they said it was going to be a 1-day lesson, and I don't know if it worked out that way or not because it was pretty darn long. A comet is an object in space consisting of ice and dust left over from the formation of the stars and planets. The speed of a comet can vary, but some comets have been known to travel over 1,000,000 miles per hour. I mean, that's hauling tail. Let's see what else they have to tell us about that. Suppose a comet is traveling at 7 to the 7th miles per hour. How can you determine how far it will go in 7 to the 3rd hours? And how could you determine how long it would take the comet to travel 7 to the 10th hours? These are some of the things that we get to talk about in this exciting lesson. Our inquiry question says, how can you simplify a product of powers with like basis? It's really pretty darn easy to do. So what we're going to do is we're going to use this sketch pad, and we're going to see exactly how we can do just that. Now our instructions say that we can drag point X left and right across the sketch pad, and that the numbers across the top of the sketch pad represent the value of X. The value of X is going to be equal to the number with which point it is vertically aligned. Okay. The value of each expression is equal to the number with which its point is vertically aligned. Alright, I guess that makes sense. And if the bars and the expressions go off the page, it means the value is going to be larger than 15. And to see the end of the bars, you have to move the orange point back to the left. Well, let's see if we can figure out how to do this. So we show set 1, and set 1 gives us X. And that X just goes to the 1 power. Okay, I see how this thing works now. This is going to be X squared, this is going to be X cubed, X to the 4th, and so on. And what we're going to be looking at here is a concept called exponential growth, where when I take my X, where X is equal to 1, all of our values are going to end up having the same solution. But if I just drug it to where X was equal to a mere 2, then 2 squared would be 4, 2 cubed would be 8, and by the time you got to 2 to the 4th, it's already off the chart. This is what we call an exponential growth, where you've got items that are expanding. Notice it's not linear, it doesn't make a line. You've got a curve going on here as it stretches out further and further depending upon how high the exponent is. Pretty cool explanation. Now we're going to look at set 2. In set 2, 3 new bars and expressions appear, and we're going to drag point X so that it does not equal to 1. So down here, we've got set 2 going on, and we can take and see these new expressions here, and when we drag X, look what happens there. Now even though our X values here are expanding at an exponential rate, these numbers down here at the bottom, those are all staying the same. What do you see here? I see X times X to the 5th. 1 plus 5 is 6. 2 plus 4 is 6. 3 plus 3 is 6. So that means it doesn't really matter how they're going to be stuck together. As long as the exponent equals the same thing, they're going to be the same exact length, which incidentally is the same as this one right here, X to the 6th power. So let's dig in and get some of the meat of this lesson, starting off with a monomial. Monomial is defined as a number, a variable, or a product of a number and a variable, and a product of a number and one or more variables. So that's your definition. And for example, 6y squared, it is a monomial since it's going to be the product of 6 and y squared. However, the expression x plus 3 is not, and the reason is because of that right there. If it had a plus sign in it, it's not going to be a monomial. If it has a minus sign, it's not going to be a monomial. When addition and subtraction signs separate an algebraic expression into the part, each part is called a term. There is another definition to look forward to on your vocab quiz. A monomial only has one term. The expression x plus 3 is going to be the sum of two monomials. Therefore, it's not going to be a monomial because it has two terms. One term is x and one term is 3. Now we're going to drag each of these into the appropriate bins. X is going to be a monomial. That is not. It's got a plus sign. That one is. That one is. This one is not because it has a minus sign. Everything checks. You can see that if it ends up with a plus or minus in it anywhere, it is not going to be a monomial. Now let's see what the textbook has to say about simplifying a product of powers.
You can simplify the product of powers with the same base. Write 4 squared as a product of factors. Write 4 cubed as a product of factors. There are 5 common factors altogether, so the product is 4 to the 5th power. Notice that the sum of the exponents of the original powers is the exponent in the final product. You can multiply powers with the same base by adding the exponents. The product is x to the 7th power.
So did you catch exactly how he worded that last part? He said you can multiply products with the same base by adding the power. So x cubed plus x to the 4th, they have the same base, which is x. So all we had to do is take the x there and then add the powers of 3 and 4 that you see here, and that gave them x to the 7 for a final answer. Now we're going to simplify a product of powers using the like basis by using the product of powers property. And while it doesn't give the definition up here, I'm pretty confident it's going to end up giving it down here. Let's get all these starting to load in words. It says to multiply powers with the same base, add their exponents. That's going to be the definition you're going to see with the product of powers property. Using algebra, it says a to the m times a to the n is equal to a to the m plus n, and then with actual numbers, 2 to the 4th plus, or excuse me, times 2 cubed, that's going to be equal to 2 to the 4th plus 3, also known as 2 to the 7th. So let's get some real world applications going on here. 5 to the 4th times 5, it doesn't have an exponent. What's the exponent going to be? How many 5s do you see right there? I see 1, so the exponent is going to be 1. So we could take and rewrite that problem as 5 to the 4th times 5 to the 1st that you see here. The common base is going to be 5. That means from there we would take and do 5 to the 4th plus 1, giving us 5 to the 5th. And then when you multiply that out, that actually would end up becoming 3,125 should they want you to actually do that. Read your instructions carefully because it may not. It may just say to rewrite with exponents. If it doesn't say to simplify the expression, you don't have to take it all the way to the 3,125. All you'd be doing is going to the 5 to the 5th. And once again, our lovely textbook, for reasons I don't understand, well, let's see what we do. I'm thinking that I'm going to put in a 5, and I'm going to raise it to the exponent of 5. And let's see if they give us that for the right answer. They do. They didn't actually want us to write it out there at all. So in simplifying the expression, I misread it earlier to you. That's not taking it to the standard form. That was just writing it as 5 to the 5th. But what if we had it with variables? Here I have c cubed times c to the 5th. If we were to take and work through that one, that would be the same thing as saying, let's here make it a little bit bigger for you. That would be the same thing as saying c cubed plus 5, and 3 plus 5 is going to equal to 8, and c to the 8th is your final answer. Now your textbook gives you a spot here you can type that in. I'm not going to do that, but you should. The reason I'm not is the answer's right there. Now it's going to be your turn. Take a minute and solve this problem. Make sure you're giving me good supporting work so you can get full credit for doing it. If you don't give me good supporting work on your homework, I will not give you credit for doing your homework. So we have a cubed times a to the fourth. We could rewrite that as a to the 3 plus 4, which is also going to be a to the 7th. That would be showing your work. That would be what I must see. And if I saw anything else, well, you'd be doing it just for fun. A to the 7th, come down, hit accept, and check our answer. The answer checks. Easy math. Now it's time we really step up our game. Here we have negative 3 times x squared times 4 times x to the 5th. And when we work this one, we're going to be using that pesky little commutative property of multiplication again, where we rearrange the order of things being multiplied, because in multiplication, order doesn't matter. So moving forward with this problem, we've got the original problem right here, and you can see the very next thing they do is break it apart. They took where they had 3 times x, they put a multiplication dot through it. The same thing for the 4 times x to the 5th, they put a multiplication dot there. Next, they're going to use that commutative and associative properties, and the commutative property said order doesn't matter when multiplying. The associative property said grouping doesn't matter when multiplying. Now, the parentheses are not really required here. They're a nice touch, grouping it together, but in the end, they don't really matter, because either way you work it, we're going to still be doing negative 3 times 4, which is negative 12. And then the next step, I have a common base, so we're going to take this being multiplied, so then it's going to be x raised to the 2 plus 5 power. 2 plus 5 is going to be 7, so our final answer is going to be negative 12x to the 7th power, which you can type there if it'll give you a warm fuzzy feeling inside. I'm not going to. The answer is right there for the whole world to see. And once again, it's going to be your term. Use your commutative and associative properties on this problem. Pause the video and make sure you are giving me good quality supporting work so I can give you credit for it. Now we're going to work this one just like the textbook did there as the demonstration. So I'm going to do negative 2 times with the multiplication dot m times, in parentheses is going to be the negative 8, and then times the m to the 5th power. Now we didn't have to have parentheses around the m. The whole reason that parentheses was there was to keep that 8 from murdering the m in front of it. So from here we're going to take and use our commutative and associative properties. So now I have negative 2 times, whoops, don't want that to happen, times a negative 8. And I'm going to put these in brackets because I had parentheses right there. And of course, that all is going to end up being times m to the 5th. Now this m right here, that's one of them. Close my parentheses. Negative 2 times the negative 8, positive 16, times m to the 1 plus 5, which means our final answer is going to be 16 m to the 6th. Come back over to our problem here, and you will see that's the same exact thing that the textbook came up with. Not too hard to do, is it? We've looked at the product of powers, where we're multiplying the number, the basis, which meant we added the powers. Now we're going to do the quotient of powers. And the quotient of powers, we're dividing them, so what do you think is going to happen to the actual power exponents themselves? Well, if multiplying, added, then dividing, that should lead to subtraction. Let's find out. Now we're going to use a web sketch pad similar to what we did earlier. And we're going to go ahead and show our set 1 there too. And once again, here you can see that we got an exponential growth going on with the numbers here. But look at what's going on down here. These are all staying the same because 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1. And if you line it up, that all lined up to this 1x right here. So wherever we have 1x, that's the same thing you're going to get on the bottom right here, because when you divide these out, they all equal 1 as well. But what if we did it to where they equal 2? So now I have x squared, you can see is right here, and it goes straight down from x squared. 9 minus 7 is 2, 8 minus 6 is 2, 7 minus 5 is 2. These as well line up with the x squared where the exponent is 2. And that kind of lays the foundation for everything that we're going to do in this part of the lesson. I think this will be a good place to stop with this part 1 of this lesson. When we come back, we're going to watch a video for part 2 on how to find the quotient of powers. I think I gave you a hint just a few minutes ago on what it's going to say.